Hi, and welcome to Unit 15 of the Illustrated Guide to the National Electrical Code. In this unit, we're going to cover the hazardous locations and the classifications in those areas. Now, there's a lot of detail in this chapter. What I'd like to do is give you the overall understanding of what hazardous locations are and how to determine what type of hazardous location and classification it is. We won't be going through every single code section, but I want you to understand what explosion-proof electrical fittings and housings are, how to determine the classifications of the different hazardous environments, and also to understand what divisions they are. And there's an easy way I want to show you to remember this for those divisions. I did a lot of work towards the end of my career in the field prior to going over to Southern California Edison, where I worked a lot in explosion-proof environments and the hazardous locations. So it's definitely a fun part of the trade, and the craftsmanship that it takes to put in conduit threaded with all the fittings that go on there and make it look really good. That was really a highlight for me, to be able to exercise that craftsmanship in what I do. And so there are more hazardous locations than just the oil and gas industry, and that's where I was at. And I started my career in the field in pipeline construction and ended in pipeline, but on the electrical side of it instead of the pipeline side of it. So understanding what goes on on both ends of of that operation. But it's not limited to that alone. We don't look to just oil and gas as being an explosion area or potential for ignition. We have other areas, and that's what I want to show you. I want to expose that to you. So again, just make sure that you are watching the additional videos, and each unit is going to have supplemental videos that help to make that point for us and learn this. So go through this section, do your best to read this one. It is a bit tougher to understand. And try to get the overall. When you do the homework, it's going to drive you back into the text so that you can answer those questions. So let's go ahead and get started, and we'll start with the overview here. So I've got two images up right now, and the first image over here on the side is a flow chart. And flow charts are used to help us make a decision, or they call them decision trees. Both of these are really handy. This one here and this one over here. Let's start to the one on the left first. The one on the left is helping us determine what article we need to look at for that location. So first, if we need to go to Article 500 to determine the class. All right, so the class is going to be gas, dust, and fibers. So the first step we need to understand is what's combustible in the area. And it could be a woodworking operation. Well, there's dust. It could be a carbon fiber facility that makes carbon fiber parts. Well, that's fibers. And there could be some dust there too from the carbon fiber dust. And it could be oil and gas. It could be explosion gases, explosive gases that could ignite. And so when we determine if, let's say, we're looking for gases, well, we come down this decision tree right here, we find gases, and then we say, yes, that's it. We go over to the class 1, Article 501. Well, if we go back to gases and say, well, it's not gases, it's a no, we go to dust, and if it's no again, it's fibers, that's a yes, then we go to class 3, Article 503. So nice thing with the code section is 501 is class 1, 502 is class 2, 503 is class 3. Once we determine that, then we have to understand the divisions or zones, and we need to be able to apply the zone requirements per Article 505 and 506. We won't get very deep into the zones, but understand where they're at, and then applying the division requirements in Article 501 to 503 on if it's Division 1 or if it's Division 2. And so this is your overview of your code. How are we going to find the section? If we have a dust environment, it's 502, Class 2. So On the right-hand side is a really good breakdown in this chart. What I like is this chart helps us to understand the first about 10 pages of the unit as it breaks it down. So the first one is class 1. So what do we see? Class 1 are gases. Gases, vapors, and liquids. Well, liquids can be combustible because of the vapors or the gases with the liquid. So if you were to take gasoline, liquid gasoline, and light a match around gasoline, the vapors are burning, not the liquid. But the more the vapor burns, the liquid off gases more gas, and you in effect feed the fire with that gasoline. So vapors, gases, and liquids that are combustible. And here's the grouping. So within it, we have a group. Group A is acetylene. Group B is hydrogen, or the hydrogen flammable gases. C is ether. And D is hydrocarbons, fuels, solvents, etc. Division 1, I want you to understand how this works. So Division 1, the easy way to remember this is all of this Division 1 is your normal operating situation. In this zone or in this division, it is where you will have these gases, dusts, or fibers on a constant basis, and is normally in that area. This is the production area. This is the supply area of the gas or the flammable liquid. So Division 1 is the normally explosive and hazardous area. And Division 2 is not normally present in an explosive concentration, but accidentally may exist. I've got a couple illustrations in the book we're going to go to, and we'll dig into this a little bit more so you can understand the difference between Division 1 and Division 2. So for dusts, they could be metal dusts that are conductive and explosive, carbon dusts, some are conductive and all are explosive. That's interesting. Some conductive, all explosive. Carbon fiber is one of those that is conductive. Flour, starch, grain, combustible plastics, or chemical dusts. So you could have a grain silo that could have a static arc event and could launch that grain silo off like a rocket because the grain dust itself is flammable. So it's really kind of thinking about flour, right? Flour is combustible. There's a few experiments you could look up. I'm not going to tell you which ones, but you can try some of these food dusts and see what they do. Be safe, please. So in the Division 1, so Class 2, Division 1, ignitable quantities of dust that is normally or may be in suspension, or conductive dust that may be present. And so in suspension means it's in the air, it's floating. So if you're in again, go back to a grain silo. A grain silo is loading, the grain elevator is going up the grain. Grain going up the grain elevator. It drops into the silo in the top to fill the silo up. It's going to create dust. So inside of that silo, it will be a Class 2 Division 1. Outside of the silo may not be a Class 2 Division 1. It may be Class 2 Division 2. That means that dust is not normally suspended or ignitable. In an ignitable concentration. So outside of that silo, there may not be enough dust because the wind would blow it away. It's not in a high enough concentration, but it still could accidentally exist. Now, at the top of the silo, outside, maybe it's not Division 2. Down at the bottom, where the grain elevator is, or around the outside of the silo, possibly could be. Dust may come down and settle in the ground area. Or where dust layers are present. Now, the Class 3 fibers and flyings could be from textiles, that's making clothes or making materials. Woodworking, so you could have obviously dust, right, with the woodworking. Easily ignitable, but not likely to be explosive. So here we don't have an explosive situation, we have an ignitable situation. And Division 1, handling or use in manufacturing. So around your manufacturing equipment, you're cutting the wood, dust is collecting. That dust will cause a potential for it to ignite. Now, Division 2 of Class 3 is stored or handling in storage, exclusive of manufacturing. So outside of the manufacturing area, it's being stored. There could be dust present. You could have a Division 2 situation there. I had a service call at a woodworking shop, and they said that the lights didn't work. The overhead lights were out. And as I traced the conduit to a metal box, I found that as I unscrewed the metal cover, industrial raised cover off the 4S box, it was packed with sawdust. I don't know how it got in there, but there was enough dust over enough years that it started collecting and it filled it up. And when it pulled it out, you could see the burned, charred dust in the back where it finally had arced on the contacts and caused it to trip the breaker. So some of these areas that you just may not think about could become an ignitable situation down the road. The idea of this section is for you to be able to get a better understanding of where you could have a hazard, for you to know what they are, and in most cases, if it's an established facility, they've got engineering on site, they already know the classifications. So then you need to ask. Okay, you're installing something around a fuel island at a gas station. Well, what's the classification? We know what the code's going to give us an understanding, but does that company have a different specification that goes beyond what the code says? So that's why we always want to make sure that we talk to the facility engineers, owners, to understand how they've designated the areas. But this should help you be able to understand the type of a flammable substance or material or gas, that how do we classify it, and then what are the Division 1, Division 2. So again, Division 1 is telling us that it's always present. There's going to be a gas vapor there all the time. There's or it could be there, and then it will be explosive or hazardous, ignitable in suspension or through the handling or use of manufacturing. Division 2 is outside of that. So if you had a concentric ring in the middle, and that concentric ring is your Division 1, your Division 2 is around that, where it could extend past that Division 1, then it goes to Division 2. So we won't ever have a Division 2 inside a Division 1 boundaries. And these boundaries are going to be three-dimensional. They are a three-dimensional cube, circle, cylinder, however it's been designed to be around that type of combustible material. And we have to know that there's height requirements, there's depth requirements underground. Again, over here on Article 500, we help determine the classes, and we would have a Class 1 gas, Class 2 dust, Class 3 fibers, and then we would go to find those in Class 1 is 501, Class 2 is 502, Class 3 is 503, and these are articles in the National Electrical Code. So I want to point out on the overview, and when you see this graphic here in the book, that it's a little bit confusing. The way they've drawn this in the picture, I would prefer to see danger in Division 1 and less dangerous in Division 2. Now, the way they use it is normal here in Division 1, which it's the normal situation, but it's the most dangerous in the normal. So this is a little bit confusing, but you can go through here and you can see everything we just talked about in that previous table that I showed you. Now, when it comes to installing in an explosive environment, or you need to put in explosion-proof electrical installations, It's very important that you understand you have to use threaded pipe in a class 1, division 1, class 2, division 1, and class 3, division 1. So the pipe needs to be installed with threads, and there is a few different types of dies that you can get for threading. Plumbing threads aren't always the best. Their pitch of their thread is too fast, but the NPT thread is going to, it's more of a straight thread for electrical. If you use a plumbing, your taper is going to be much greater, and all that means is that you're going to be seating that much farther into that hub that you're screwing it into. The most easy way to do it is obviously with we call them a porta-pony, portable threader, and they have a table threaders. And I will give you this piece of advice that it is very possible to be good at bending conduit, where you will cut and thread the straight conduit and then bend it and put it in, and it'll be exactly where you want it at, completely cut and thread. If for some reason you're trying to do it the quick and easy way, and that would be to bend it and then thread it, for the smaller pipe, you can't use a table threader. You have to use a portable threader. Do not put a piece of bent material into a table threader. It will tip the table threader over if it's too long, or injuring somebody. It's like a propeller going on the end of that threader, and that threader has a lot of torque, so it'll just completely come around and tip the table over. But you can get good enough at pipe where you cut and thread the straight piece and then bend it. So it's pretty cool when it works out like that. When we look at the different styles of explosion-proof boxes and enclosures, we find that they're much heavier duty, most always cast iron, and they'll either have a flat flange and bolts all the way around, or it's a threaded, screwed in hub lid to it. The smaller boxes will be the screw-in ones, and then your larger ones are going to have this flat flange on it. Now, the idea is, and what they're trying to show you here, the idea is, with the way this is installed, that you contain the arc in the box. And if you contain the arc in the box, there's going to be an expansion of the air. Every time you have an explosion, you're going to expand the air inside the box, and you need to have a way for it to get out. And the way this is designed is it's not completely sealed from the inside out. So when there's an expansion, the gases will go through the threads, and the intention is there's enough thread there that the gas is cooled by the time it escapes from the box. And the flange is thick enough or wide enough that the gas is cooled on the way out. So that is the principle behind making sure that we contain the arc in the box, and that whatever escapes out of it is not hot enough that it can ignite the vapor in the air around it. Now at the bottom of the page here, we see that there are different style of enclosures, and we have some that are just a dust tight enclosure, where they're not explosion proof, but they're dust tight. And then we have some that are completely explosion proof bolt downs. Here's the bolted flange I was talking about. This is actually a panel board, explosion proof panel board with individual breaker throws connected to the inside with the mechanisms, and the main breaker out on the outside. And so this is not explosion proof, but it's dust tight. And this here is an explosion proof. So you may have this in your class, in your division 2. Division 2 here for dust. And this would be in your division 1 for the class 2. So class 2 division 1, class 2 division 2. The more the cost goes up much higher when you're in the division 1 requirements. Other protection techniques for the field wiring. One is an explosion-proof incandescent fixture or explosion-proof light fixtures where the breakage of the bulb, if it were to blow, will stay inside. The filaments inside or anything that can ignite is contained within the fixture itself. So glass globe, it's a thick enough glass that it will withstand an explosion inside. And same thing with fluorescent fixtures. The tubes are enclosed inside this thick glass, and all of the ballast and all the electrical components are all sealed up within the fixture. Another common device is called an explosion-proof seal, and there's different types. There's a horizontal and vertical seals, or each of these all have a letter code. These were called EYSs. They're EY with a seal, S for seal, and I'll show you those here in just a second. And then explosion-proof flexible coupling. These come in short lengths, but if you need to have a flexible fitting to a motor that's an explosion-proof area, you can get a flexible piece of explosion-proof conduit for that. And then your boxes are like this, and you would order them based upon the type of hub configuration. You could have 4 coming in, you could have 3, you could have 2, you could have it coming out the back. There's all kinds of combinations that we can get for boxes like this. It's important to note that when you're in a Class 1 Division 1, the requirement is that you have 5 threads that are fully engaged into the hub. And the reason for this is, going back to what I had shared towards the beginning, was if there was an explosion in this pipe and the gases would have a sufficient surface area to cool before they escaped out of the threads. So it's really important that we have that 5 thread of engagement into the box or into the hub. Now, you can have a situation where your threader is not set properly to depth, and you go to screw it into the hub and you get in there for 2. Those threaders are all set up for different types of pipe, and you need to monitor that, watch that, make sure if it doesn't screw in all the way, go back and look, because maybe there was a problem with the way the die was set up for the depth of cut. Or you have the wrong dies in there, possibly too. The thread pitch is wrong. A trick that I found was when a factory piece of conduit, GRC conduit, is galvanized, they galvanize the threads also. And what I like to do was take the threader and run it over really quickly over the threads of the factory end, so that it would screw in easily into the fittings. And as long as you're not going deeper, you're fine. So all you're doing is just taking the outside coating off and you're screwing it together. This conduit in some installations can be put in as just bare GRC, and in others it needs to be a plastic coated pipe called OCal. That's a brand, but it's plastic coated all the way up to the threads, and then the threads have a special paint on them. So if you do what I just said, and I've never had a problem with OCal doing it, but you need to treat the threads before you put it all together so that it's protected from corrosion. It could be down saltwater area where it's just a salty environment and you want to protect the pipe. OCal or plastic coated rigid is what's normally required for underground when installing around explosion proof environments. So when you put this together, they make a special OCal coupling that's got rubber coming off the end of it, and it will cover everything up, and then you use tape, rubber tape, to tape it up, and you seal it all up. In some situations, when you're in Class 1 Division 2, you can run the equipment bonding jumper inside the raceway. That's the way I prefer it. Or you can run it on the outside, as long as it's run with the raceway and zip tied or strapped to the side of the conduit. Now, when we talk about putting in seals, and in both Class 1 Division 1 and 2s, there's a 10-foot requirement. You can either put the seal 10 feet into the hazardous area or 10 feet maximum on the outside of the hazardous area. I usually would put them up, especially if they came up out of the ground and they were going into a building and they were coming from an explosive area, ignitable gases. Is I would come up out of the ground and then put all of my EYSs right there along the side, and they're easier to install when they're vertical, and then they would go into a box and go into the building. So the gases in this EYS and the seal are kept to the side where there's so going down in this EYS is going towards where the gases are at and the explosive environment. And what you do is you put a fiber material in there to dam it up around the wire, and you got to put it in through this little small threaded hub you pull out. And then you mix up and pour in the sealant compound. And then once the sealant compound is dried in there, it seals off the vapors from coming up the conduit and into the building. And sometimes you'll get condensation buildup, and these EYSs will get water actually standing in here. And it's advisable in areas like that or conditions like that, you get one with a drain in it. There's horizontal. You've got to put fiber at both sides, and then you can fill it then with the main plug area. Now let's talk about a couple of installation locations. So when we look at Miller's Auto Repair here in this diagram, we see that there's a pit for the mechanic to go down and work in the pit. And they may not have lifts at this location. This could be an alignment shop, could be an oil change shop where they don't want to lift every car. They just want to drive them up on the pit, and there'd be somebody down in the pit working. So what we see here is that in the pit, if it's ventilated, it would be Class 1 Division 2. So a ventilated pit where they're pulling any vapors into a special ventilation system, that would be a Class 1 Division 2 in the pit and above the pit, 18 inches up. And here goes this three-dimensional layer. Now, if it is an unventilated pit, that now becomes a Class 1 Division 1. And then above that pit, you would have a Class 1 Division 2. And so again, this is that concentric layer. Concentric is related to a circle, but giving you the idea, they're layers as they go out. The Class 1 Division 1 stops because vapors, this is a Class 1 Division 1 because vapor can sit in this pit. Vapor is heavier than air, and so the vapors are going to settle down to the ground. So you may have Class 1 Division 1 down below a tanker truck that's offloading gasoline or loading gasoline, and above it you have Class 1 Division 2. So you have down below is where all the vapor is settling onto the ground. And then your three-dimensional layer up, now you go above that in your Class 1 Division 2. So when you get to the top, for example, right here with these lights, it says that that the pendant right here, for pendants, flexible cord suitable for service type listed for hard usage shall be used. So it's above, outside of the hazardous area, and you can use a regular fixture in this case. An interesting note is that parking garages used for parking and storage are permitted to be unclassified. So although we have vapors from vehicles, they could have a gas leak, right? They could have an oil leak. There could be something flammable coming from them, but they normally wouldn't. So the difference between a parking garage and an auto shop is going to be exposing those fluids, working on the fuel pump, working on a fuel filter, changing the oil. All of those things are going to expose now a flammable liquid or gas into an environment where a parking garage is not considered that because it doesn't normally have that accessible. How about a filling station where we're going to fuel up? We're going to have classified areas here. So here's an example of that. So this is those layers I was talking about. Around the pump, we'll start here at the pump area where we're going to be standing. So 18 inches from the pump, you're going to have a Class 1 Division 2 location. And then it comes down, and then it hits a much wider 20-foot diameter or oval, 18 inches up from the ground, 20 feet in an oval around that filling island, will be a Class 1 Division 2. But it's 18 inches up, again, because vapors are going to sit closer to the ground. And then below ground, it's Class 1 Division 1. Well, you're probably thinking, well, what's going to be underground? What about conduit? Conduit coming in to feed this is considered Class 1 Division 1. So we would need to treat this with an explosion. We're going through an explosive area, Class 1 Division 1. That means we need to put a seal in on the unclassified side because it penetrates and runs through, and it's if there's a break. So I believe that's still kind of the workaround, is you can pass through it if there's no break, which means couplings, boxes, fittings, anything like that along the way. But this would need to be in rigid conduit. I have worked around aircraft hangars, and in Los Angeles basin, it is highly possible you could be working in multiple different environments. And I had worked in an aircraft hangar, getting it ready for putting a security system in. They were going to do some R&D on a special aircraft, and they wanted to get it secured. And so when we look at the aircraft, we see that the wing and around the engines are Class 1 Division 2. The wings have bladders in them that hold the jet fuel. So the wings are the fuel tanks on any type of jet plane, and then your engines have jet fuel around them. And so if you have a wing mounted, tail mounted engine, then you'll have an area around it that is considered a Class 1 Division 2. But the rest of the plane in the front is not. And if there's no engine, the tail is not. And then inside the entire hangar, 18 inches above the floor, is Class 1 Division 2. So we have, if you're going to install anything, keep it above 18 inches if it's just going to be around the side. So like when I put this security system in of basically shooting beams all the way around, up the sides, we made invisible beam curtains to inhibit anybody from, or at least tripping an alarm if they were to try to come into this hangar. Everything was above. We were 6 foot or higher where we installed it at. But if there's any sump wells or a catch basin, anything inside there, that's now Class 1 Division 1, because that's where the vapors are going to go in, and they're going to settle down in that location. Now, in this one here, we're looking at a spray application, dipping or coating, painting process where there's flammable liquids around and combustible materials. And we have to look at how this has been classified. This is where you're going to really get into specifics of the customer's facility, having an engineer that has designated this so you know. But if there's electrical on this piece of manufacturing equipment, you're going to have to treat it as though it was in a Class 1 Division 1 location for this example here. And then this one here is showing how it will extend past, and you will have a Class 1 Division 2 on the outside of that. So just giving you a couple of options. Again, with your grains, flours, that you could have dust suspended in the air, you will have areas around this silo grain storage facility. You're not going to see a lot of those around here, but if you did travel or work in the Midwest, you're going to still see grain silos all over the place. And this is where they're going to, the farmers are going to bring their crop in, and it's going to get stored and then sent to market. So these are the intermediate storage facility before it gets sent out to sell. But around your grain elevators, your tubing, the chutes that go into the silos, in the silos and around them are going to be a hazardous location where dust can be. I believe I may have a video that I included. And if I didn't, you can just look for silos that caught on fire or exploding silos and watch what happens when that occurs. Now in the textile production where they're producing sheets of cloth that are going to be made into clothes, we're going to see that the dust that's generated from that will also be an ignition problem. There's been more places I've gone into over the years where they were having mechanical issues or electrical issues that were caused by poor maintenance. So when you have these environments, now you have a preventative maintenance situation that you have to stay on and make sure that the equipment is cleaned out. Shutting the manufacturing lines down, vacuuming out all the nooks and crannies and crevices, making sure that it's all clean so that you don't have a problem with combustibles getting stuck or in the niches and the nooks and crannies of the equipment. I had a situation where a company was creating carbon fiber parts for flight hardware was consistently calling us with problems where they were saying their adjustable speed drives were failing and they were having basically blaming on voltage issues. And an inspection of the facility found that there was carbon fiber being produced, and everything close to the carbon fiber production area was what was failing. Carbon fiber is conductive. And so the dust goes in and settles inside of the equipment and the electrical drives and causes it to short circuit across the terminals inside. And there was dust in there. It wasn't just a theory. I opened it up. We looked at the drives. Sure enough, there was a layer of carbon fiber dust on there. And being carbon fiber, it's conductive. So you have to look at that installation as a whole. And they weren't treating it as a hazardous classification. There was another situation where the carbon fiber dust went into telecom equipment and shorted out the telecom equipment because it was installed in that room, but they didn't think about it being utilized for carbon fiber, or maybe it was later on used for carbon fiber and it became conductive. So your wood plants, lumber, pulp mills, pulp prior to it becoming, getting it wet, you're going to have combustible dust. I have a table saw, and one day it just stopped working. I smelled a little bit of electrical burning going on, and I thought, oh boy, I just burned the motor up. I didn't burn the motor up. The switch it got full of sawdust, the enclosure on the outside of it. And I'm pretty meticulous about my tools. I blow the dust off every single time I use it, clean it out. But the dust was just kind of getting into a little hole in the back where the wire came in, and it just filled it up and caused it to short out. Now, the other location that you could see is where they're baling textiles or they're storing that material. You can have dust in that location. They were considering that a Class 3 Division 2 where that storage is. So again, let's just look here really quick. We've got Class 1. Gases, vapors, and liquids is Article 501, and that could be acetylene, hydrogen, ether, hydrocarbons, fuels, solvents. Dust is Class 2, Article 502, and that can be metal dusts that are conductive and explosive, carbon dusts that are conductive and some explosive. I'm sorry, some are conductive and all are explosive. I said that backwards. And then flour, starch, grain, combustible plastics, or chemical dusts. Those are all dusts that could ignite. And then Class 3 is fibers and flyings and textile, woodworking, easily ignitable but not likely to be explosive. So it doesn't take much for fires to start, and you could have a fire start in an area and then it causes an explosion in another area. You can find plenty of ammonium nitrate storage facilities on YouTube that have blown up, and we know of a major explosion recently in Lebanon. So we can have these massive explosions by materials that are technically not flammable by themselves, and then become flammable by something else. Not sure still what caused the massive explosion. They said there was a fire nearby. but it wouldn't take much if there was a fire in a building close by to cause enough heat to cause the ammonium nitrate to blow up in the silos there that we're storing it. So there's a lot of chemicals that are dangerous and hazardous for many different reasons. But here, when we talk about the explosion areas, the areas that you could have hazard and causing an explosion, you definitely need to be aware of them, understanding what the Division 1 and Division 2 is. So hopefully this was helpful for you. I know that when I learned about this, I didn't really dig into it until I was working in it. It's one of these code sections that if you're working in this area of the hazardous classifications area, you're going to know this, and you need to know where to go to get it. That's why I recommend keeping that illustrated guide, making sure it's handy along with your code book somewhere, and you can go and reference it and get specific into the text to be able to install the installation safely. So again, I hope this was helpful, and look forward to seeing you guys in the next lecture. Take care and have a great day.